So we're going to look at natural exponential growth and decay. So it's not any different from exponential growth and decay. If you remember, exponential growth kind of went this way, right, where a was greater than 1, and then decay went sort of this way, where a was less than 1. So the natural exponential growth and decay is going to work pretty much in the same way, except my base here is going to be e, right? So we say that, so natural exponential growth and decay is model, so natural exponential growth and decay are modeled by the formula f of x equals p times e to the rx. Okay, or if you want to just think about it as f of t equals pe to the rt. So just think about your compounded continuously formula, right? And that's the same formula you're going to use for exponential growth and decay. Now, the only thing here is if your rate is greater than 0, right? So if I have my exponential growth rate comes out to be positive, then this is going to be a growth. And if r comes out to be negative, it's going to be decay. Okay, so it's the same as your, think about it in terms of money. If I had a negative interest rate, you would lose money. If you had a positive interest rate, obviously you'll get more money, right? So if r is positive, this models growth. If r is negative, this models a decay. All right, so let's take a look at an example. So let's see, Tom bought a new car worth $30,000. All right, and the car depreciates at an annual rate of 10%. So as you know, after you buy a car, as time goes on, the value of the car obviously decreases, right? So here we know that it's supposed to be a decay because it's a depreciation, right? So that word sort of tells you that the value is decreasing, all right? And so actually it's not a 10%, but think about it as a negative 10% because the value is going down. And so what is the value of this car going to be after 5 years? So we know that we're going to have to use the formula A equals PE to the RT, or like I say, PERT, right? Now, P is 30,000, okay? R is 0.1, that's 10%, but like I said, it's a depreciation, so R actually would have to be negative. If you made R positive, you will notice that the value of the car actually becomes more than its initial value, and you know that's where you went wrong. So it's going to be negative, and then the time t is going to be 5 years. Okay, so let's go ahead and input that in our formula here. So I get 30,000, okay, e to the negative 0.1 times 5, and that gives me a value of $18,195.92. So at the end of 5 years, Tom's car is now worth $18,195.92.